Same section, turning things around a little bit. If I were to give you this information, if sine of A is equal to 5 over 13 and tangent of B equals 33 over 4, where A terminates in quadrant 1 and B terminates in quadrant 3, find the following. That's just the instructions for the problem. If sine of A is 5 over 13, tangent of B is 3 over 4, where A terminates in quadrant 1 and B terminates in quadrant 3, find the following, okay? Now, we're talking quadrants again. What do you think we have to, before we can do anything, we've got to do some prep work, okay? So here we go. So here's our prep work. We're going to have to use, have you seen this before?
Yeah.
What is that? All-star trig class. Now, I've got to put one triangle in quadrant 1. And it says that angle A terminates, here's the angle, means it stops in quadrant 1. So angle A is this angle here closest to the origin. It's in quadrant 1. It says its sine is 5 over 13. There it is, 5 over 13. Sine is 5 over 13. I just got finished teaching this in geometry. Folks, do you remember your trig ratio, your little saying? Some old horse caught a horse taking oats away. Some of you did not remember that one because you remembered. Some old hippie. That's the one you remember. That's the one you always remember. Okay. That's what we have to go back and revisit. I'm going to revisit the old horse. You can revisit your old hippie. But you shouldn't. I don't encourage that. All right. So there's angle A right here. Sine is 5 over 13. Sine is some old horse. It's opposite over hypotenuse, isn't it? So in relation, with respect to angle A, its opposite side is the upright side or the base of that triangle. It's the upright side. That's the opposite. So that means the opposite is 5. The hypotenuse is 13, which the hypotenuse is always the same spot. It's always across from the right angle. Folks, how can I find that third side? The Pythagorean theorem. Does anybody recognize something about these numbers? 5, blank, 13? It's a triple. What is it? 5 what? 5 what 13? No. No, don't go through the numbers until you get the right answer. If you didn't know, how would you figure it out? Pythagorean theorem, right? Okay, you ought to know these. Here we go. I use my version. I know y'all use your version. It's okay. My hypotenuse is 13. The leg is 5. We got to find the other leg, correct? 13 squared is what? 169, which is equal to 25 plus x squared. What do I do now? Come on, y'all. Subtract 25. When I subtract 25 from 169, what do I get? 144. So my base is 144. It is 12. Because you're going to take the square root of both sides. So we get x is 12. Do you remember that triple? 5, 12, 13. It's always the second one I teach. What's the first one? The easiest. 3, 4, 5. Who taught you geometry? All right, 12. So 12 for that base, right? Are we done? Nope, we got another triangle. Where is it going to lie? In quadrant 3. I'm so jealous of your t-shirts.
You're going to come, right?
Of course. I'm selling tickets Friday night. I can't. If. So, for quadrant 3, which is going to be here, throw that altitude up there. Our angle B is here. And we're told that our tangent is 3/4. Some old horse called a horse taking oats away. No, no. Tangent of B. All right, B is here. It's opposite, what was it? 3. Opposite is 3. Adjacent is 4. So what's the hypotenuse? You should know this one. 5. This is the triple. Delayed. All right, so we have everything in there. Now, what are we going to do with this information? We've done the prep work. Now we've got our 2 triangles in there. What else about the All-Star Trig class do we have to be mindful of? We got to be mindful of the signs. Okay, depending upon which quadrant these angles lie. Over here, we know we're going to have negative, negative for cosine and sine, which means tangent has to be what? Positive. And then how about quadrant 1? Do I really need to be concerned about signs over there? Why? Because it's all positive, so I don't need to really worry about them over there. Now, what are we going to do with this? I don't really need this here. Here we go. We've got all our prep work done. We've got our Pythagorean triple. Now, we're going to use those 2 triangles to solve this problem. Using the addition formula for sine, and going straight, bless you, going straight to your card. The sine formula is, using our angles A and B, we would have sine of A, cosine of B, plus cosine of A, sine of B. Now, all we're going to do is go back to those right triangles. Some old horse called a horse taking oats away. Folks, what would the sine of A be? What would the sine of angle A be equal to? This comes straight from the card. Yeah, came straight from the card. I just put in, instead of S and T, I put in angle A and angle B. Sine is some old horse. Here we go. Folks, if we're looking at angle A, what's the opposite over the hypotenuse? 5/13, yes or no? Yeah. So we got 5/13 times, what's the cosine of B? What do we think of? Some old horse. Caught a horse. Adjacent over hypotenuse. 4/5, and it's cosine. So what's the sine of cosine? Negative 4/5. What's the cosine of A? Some old horse caught A horse, 12 over 13, is that what you said? And then the sine of B, some old horse, opposite over hypotenuse, 3 over 5. And sine is going to be positive or negative. Negative 3 over 5. Yes or no? Yeah? Are we okay so far? This could get confusing. I might have to do a little more prep work for myself. What do we do now? Yeah, you just multiply straight across. 5 times negative 4 is negative 20 over 65. No. Oh, you could. But I'm going to show you why you don't want to do that. What's 12 times negative 3? Negative 36 over what? 65. I want common denominators. Okay? Yes? I do. Why? Plus a negative. I just made it a subtraction. And then what would that exact value be? Negative 56 over 65 is sine of angle A plus angle B. What do you think? How to get the negatives. The negatives are based on the All-Star Trig class. Here's what I'm thinking I might do for the next one. I may do a lot more prep work because I don't want to fall into the trap of finding or having careless mistakes. I referred to this, Ross, because my cosine in the third quadrant is negative, my sine is negative, my tangent's positive. So that's how I was careful about these two signs here with negative 4/5 and negative 3/5. But I may, and you may want to do more prep work in order to do this as well. Okay? Let's try another one. Same triangles. Same triangles. And you've got it there in front of you. Or maybe it's on the other side. I want you to find the exact value for cosine of A minus B. Cosine of A minus B. Pardon me? Yeah, you can use the information you already have. Nobody's going to watch it. Let's get real. Exactly. Hey, find tangent of A minus B. Find that for me real quickly. Same triangles, same everything. Different formula. And old school. All right, formula. Tangent A minus tangent B. All of that over 1 plus tangent A, tangent B. Okay, again, I've got to refer back to that very first slide where we had those two triangles, okay? I have to list my numerator divided by my denominator. That's just me. I do not want to deal with a fraction within a fraction, okay? So I'm going to go old school. The tangent of A, what is the tangent of A? You help me out. Look back at the picture. The tangent of A. All right, here's angle A. Tangent is some old horse caught a horse taking oats away. Opposite over adjacent. So what is tangent? 5 over 12. This is pain in the butt. 5 over 12 minus, what's tangent of B? All right, again, with respect to B, opposite over adjacent, 3 over 4, and tangent is going to be positive. Would y'all say 3 over 4? All right, there's that. Divided by the denominator, 1 plus tangent of A, it's already there. 5/12 times tangent of B, which was 3/4. And now it's just fractions. All right, what do I have to do with my numerator, folks? I got to have common denominators, which is going to be 12. So 5/12 doesn't change. 4 goes into 12 3 times. 3 times 3 is 9. And then, holy moly, we've got 1 plus 15 over 48. Do you guys agree with that? Yeah? All right, keep going. With me so far? You see what I'm doing? Okay. We got negative 4 over 12 divided by 48 over 48 plus 15 over 48. Why did I do that? Because it's a 1. Okay? Got to have like denominators. Holy moly. 48 plus 15 is what? 63 over 48. Now what? Multiply by the reciprocal. And I'm going to cross cancel what? 12 goes in 12 once. 12 goes in 48 4 times. Bless you. What do you end up with? Negative 16 over 63. How many of you got that? Very good. Very good. It is so much easier for me to go old school on this than go fraction within a fraction. I do not know why. Maybe I've just conditioned myself to do that. Yes, ma'am. Is that good? So negative 16 over 63, what do you think? You're going to have to work with those right triangles in the quadrants and be careful of the signs, okay? Thank you. Questions at all? Cool.